Hello students, today we're going to continue our discussion about the metric system. Previously we talked about length. Today we're going to focus in on mass and some of the metric systems or metric units that are used in recording mass. Again, in our unit 2 we're going to talk about a couple of things. So I'll remind you, previously we've talked about length, so we know that as a distance between 2 points. Today we're going to focus in on mass. And our definition for mass is the amount of matter in an object. And the base unit, if you remember the metric ladder, the base unit is in the middle. So the base unit is going to be grams for mass. Our next class we'll be talking about volume. After we do volume, we'll talk about density, because density is a relationship between mass and volume. So that'll be coming up. Okay, so today our focus is going to be on mass. Okay, so we're going to talk about mass today. So going into the slides, last class we discussed some of the differences between English units and metric units, and again in science we primarily focus on our metric units. So we're going to look at this comparison to give you somewhat of an understanding of how they line up or match up. So if we're looking at 1 pound versus 100 grams, which one do you think is larger? Is it 1 pound or is it 100 grams? From the information we know that 1 pound is a lot larger. 1 pound is about 400 and a little bit more grams, so 453 grams is 1 pound. So the gram as a unit measures smaller quantities. Alright, even if we're comparing 1 kilogram to 1 pound, then which one is larger? So when we take our metric unit up to the kilogram from the gram, we'll see that 1 kilogram is going to be larger than 1 pound as far as a unit is concerned. 1 kilogram is about 2.2 pounds. And then if we're looking at ounces and milligrams, we'll find that 1 ounce is larger by quite a lot than 1,000 milligrams, because 1 ounce is about 28,000 milligrams. So just a little comparison as far as English units versus metric units. So over here to our definition, we know mass is the amount of matter in an object. So mass is referred to as the amount of matter in an object. And again, that definition will also be on your Quizlet set for this unit. And our base unit for mass, our metric base unit for mass is going to be gram, which is represented by a lowercase g. Okay, so we have a few conversions here, and you guys know that we're working on a lot of metric conversions in this unit. So 1 kilogram is equivalent to 1,000 grams, and then 1 gram is going to be equivalent to 1,000 milligrams. So based on that information, and for those of you that know how to do the table, you can also use the metric ladder, You can use the metric ladder that we talked about last class when we went over length. I want you to go ahead and pause the video right now and answer these questions. I will need you to bring these questions with you to next class. So you're going to answer which is larger. A, 1 kilogram versus 1,500 grams. Then you'll do B, 1,200 milligrams or 1 gram, which is larger. C, 12 milligrams or 12 kilograms. And D, 4 kilograms or 4,500 grams. So go ahead and pause the video right now, get out a sheet of paper, and answer these 4 questions. Okay, now that you've answered the 4 questions, we're going to move on. And in moving on, we're going to talk a little bit about the triple beam balance. While in class we'll use electric balances quite more often than triple beam balances, it's still important for you to know what a triple beam balance is and how it operates. And essentially that was a picture, if we back up real quick, this is a picture of what the triple beam balance looks like. It's called a triple beam balance because there are 3 beams that help us figure out what the mass is of the object. Alright, and this is what we call the scale pan or the scale. Alright, so when using the triple beam balance, essentially we take objects, we place it on the scale, we move the weights that are on those beams until we get the lines on the right side of the scale to match up. And again, if I were to go back, This is our scale. These are the beams with the weights. And there are two lines right over here that need to match up. And again, we'll get practice with this in class. And pretty much how it works, once you've balanced the scale, so once those two lines have matched up, you add the masses of the object in the picture. So again, there are three beams. Each beam will have a different mass on it. And once you add those up, you'll get the total mass of that object. So if we look closer at it, again, here's one beam, here's another beam, here's a third beam. So we'll have to add the masses that are represented on these beams together. So here, if you look, we have 300. In the back here, we have 70. And if we look closely at this, this is about 3.4. So when we add these together, we'll get whatever object that was, it weighed 373.4 grams. All right, always remember to include your unit. Now I know this looks simple, but again, we'll get practice with this in class. Moving on is a order at which you use the triple beam balance, and this will go through it, and again we'll practice in class. But first you need to place the object on the scale. So the first thing you do, you place that object on the scale. Of course, you make sure all your weights are at 0, and you place your object on the scale. Next, you slide the large weight until it drops below the line, and then you move it back until you can get these lines to match up. So you sludge the large weight until it drops below the line, and then you move it back one spot into place. Third step, you're going to repeat that process with the weights in the middle beams or on the top beam until it moves back up, the line moves back to the groove. And then the last step, you'll slide the small weight in the front of the beam. So we'll do right here, the front of the beam, until these lines right here match up. And again, we'll get practice with this once you get in class. And then, like we did before, you're going to add the three masses together to get the complete mass for the object that you're weighing. Okay. Other thing that we'll be doing, so if you remember our metric ladder. Again, this is our metric ladder. We used it when we were talking about length. Again, we're going to use the same ladder when we're talking about mass. We'll use the same ladder also when we talk about volume. Okay, so we know gram is our base unit for mass. So the gram is going to be in the center of the ladder. To the bottom of the ladder, or to the left side, on our left side of the ladder, right side of the ladder, we have our smaller units, decigram, centigram, milligram, right? And to the left side, we have our larger units, decagram, hectogram, and kilogram. And again, I used the mnemonic King Henry died by drinking chocolate milk. So King Henry died by, representing the base in the middle, drinking chocolate milk. And again, you can make your own mnemonic, but this is the ladder that we use to do our metric conversions. So when we get in class, be prepared to do some metric conversions using the ladder. So make sure you're familiar with the ladder, kind of review what we did with the length conversions, and be prepared to do some more conversions when you get in class. Again, if you have any questions, feel free to leave comments below the video or send me direct messages. Have a great day.